Okay, so I'm going to show the answers and talk through them. Just follow along. For number 1, they asked to, determine if this was a direct variation or an inverse variation. So you had to do one of two things. Either divide y by x for each of these and see do you get the same number. When you start to do that, you realize immediately that no, you don't. So it can't be a direct variation because that's how we would find if it's direct, by dividing. So then instead start multiplying. And when you multiply them, they need to all be the same. When you do that, they are all the same. And because we now know that would be an inverse, we could use the equation or find the equation using our k values to write y equals 15 over x. Do you have any questions on number 1? Yeah, to see which one it works. You could have maybe guessed that it was going to be inverse, started multiplying and saw that they all worked, and then not have to do the other one. But if you started off doing one and saw that it didn't work, then you'd have to do the other one. For number 2, they give you this 0.21 and they tell you it's a direct variation. They want you to plot 2 other points. So you have to remember that direct variations are lines that go through the origin. So you could have used like your origin and maybe this point, or maybe the origin and this point. Really, any of these points would work, but you just needed 2 others. So you could count your value of k, go up 1 to the right 2, to get like a slope of 1/2, and any point that would fall on that slope line would work. Questions on number 2? For number 3, they tell you that it's an inverse variation, so you have 2 different ways you could go about solving this. One is the method where you set these equal to each other, multiply them together, and then solve for y. The other is solving for k, putting it into your equation, and then putting your missing values into that same equation and solving for y. Either way, both of them get the same answer. So you could have done that either way, doesn't matter. Questions on number 3? For number 4, you needed to determine which one of these she labeled incorrectly. So the first one is a direct. It's in the format y equals kx. The second one was an inverse. It's in the format y equals k over x. The last one, however, was incorrect because this should have been a direct variation. It's still written in the form y equals kx. Our k is just a fraction. If our x was in the denominator, then it would be an inverse. So if it was like y equals 1 over 5x, that would be an inverse. Questions on number 4? I don't remember if 5 got put on the front of this or the back. But for 5, I'm just going to talk through this. Here, it doesn't give you words to tell you if it's direct or inverse. You have to figure that out. But as we look at these numbers, since we know y is the total amount of money, and x is the total amount of hours, as we're looking at the hours, they go up, as we're looking at the total amount, they go up. Since they both go up, there has to be a direct variation. If they both went down, that would also be a direct variation. If one went up and one went down, that would be an inverse. So it just depends on what's given. Since this is a direct, we can find our k value. We need to find our equation. So we can find our k value by taking either these first two or the second two and dividing them to get 6. So our equation would be y equals 6x. Do we have any questions on number 5? Did anyone have Khan Academy or Delta Math questions that they wanted to go over before we continue with our notes today? Okay. Before we go on to our notes, I did want to mention this, so it's all on our radar. In the event that we do still have school and there are no snow days, what's today? Wednesday? Friday is you guys' benchmark for those choosing to take that. Remember that all of your benchmark work needs to be done before you can take the benchmark. You will have time in class to finish that as well, but the more time you take to finish the benchmark work, the less time you'll have to take the benchmark. Keep that in mind. I will be after school today and tomorrow. Granted, if we have a snow day, that'll change. That way you can continue working on those if you need to. Anyone have any questions about the benchmark? Everyone should have notes that look like this. Make sure those are in front of you. So this first page is a lot of review. It's putting all of the direct and inverse variation kind of together so we can compare them. So let's do that really fast. I'm just going to talk through what's given here. So for a direct variation, to find a k, it's a ratio, y over x. For inverse, it is a product, y times x or x times y, either or. The equation of a direct variation is y equals kx. The equation for an inverse is y equals k over x. And you can see the different examples they give you. How do you test for it is really just to find your k. If your k is the same in all of your ordered pairs or your table, then you can say it's direct if you divide them all and they're the same, or inverse if you multiply them all and they're the same. For the graph, direct variations are lines that go through the origin, which means it has a y-intercept of 0. For inverse, it creates a hyperbola, or the weird looking thing. Sure. You don't need to know how to graph this, you just need to be able to recognize it. And then solving for the missing values, you can use this method, the proportions or the equation. They're both technically equations. Or the method where you find k, put it into the equation, and then solve for said equation with the values given. Okay. Today, we're going to be talking about joint and combined variation. Some of that is just going to be, maybe one problem is direct, the next one is inverse. So instead of just all doing direct or all doing inverse, it might flip between the two. Some of that is also, we might see direct and inverse in the same problem. So we'll touch on that, how we would do that. Before we get into that, we're going to go through some of these examples really fast. Not all of them, because I'm going to let you guys do some. Just to determine, are these direct variation, inverse variation, or neither? I'm missing. So for number 1, would these be, or would this be direct, inverse, or neither? Inverse. Number 2, would this be direct, inverse, or neither? Are you sure? It looks like it's direct, but does it have a line of 0? No. So this would be neither. Number 3, you would need to solve for y. X over 4, or you could write that as 1/4 x. Would that be direct, inverse, or neither? Not inverse. Sorry, my x does look like it's in on there. It's next to it though. Direct. It is a line. It's in the form y equals kx. It has a y-intercept of 0. For number 4, we could solve that one for y, but that also looks like how we would find one of the k's. X times y equals k. Would that be direct, inverse, or neither? Inverse. So if you recognize that this is the same thing as k equals y times x, you don't need to solve for it. Right, let's skip around to number 9. We'll just do one of these tables. If you think it's inverse, multiply them, see if they are all the same. If you think it's direct, start dividing y over x, see if they're all the same. And tell me which one it is. Yeah, inverse. Could we multiply these and they were all the same? What did we get for our k value? Right? I know we went through those kind of fast, but do we have any questions on any of those? We're going to jump to the back of this page. So we should have time at the end of class, and you guys can go back and practice the ones we didn't do on here. So yeah, yeah. Mr. Nova, can you write a pass? Can you write a pass? Alright, flipping to the back. We're gonna do the graphs. Is 15 direct, inverse, or neither? What did you say? Direct. It is a line that goes to the origin. 16, is that direct, inverse, or neither? Direct. I'm sorry. This one is neither. I'm doing all of this. It is a line, but it doesn't go through the order. Number 17. That one is inverse. And 18. That should be a neither. Because it's not a line and it doesn't look like this. It's actually a quadratic. $19 is similar to like the tables, but you have ordered pairs. 20 is the only one that looks a little different, so I'm just going to kind of talk through how you do it. This is a mapping. For each arrow, think about that as like an ordered pair. So this would be the point through 2, 6, 4, 12, 8, 18, 12. And then you could do either divide them or multiply them. But you would just look for what's connected to what to find them. Moving on to the next page. Before we do anything, change this wording to inversely. That was a typo. Okay. So when we do these, some of them are going to have the same kind of setup as when we were just doing direct or just doing inverse. But some of them are going to be a little different. So like this first one, we know it varies directly. If this just said y varies directly with x, we could write the equation for it, y equals kx. But it says y varies directly with the square of x. 1, the square of x is x squared, not the square root of x. It would say the square root of x if it was the square root. To try not to confuse those two. But if y varies directly with the square of x, now we would use that same format, y equals kx, but instead of this x, this would be x squared. For this next one, same thing. If this said y varies inversely with just x, that would be y equals k over x. But here it's inversely with the square of x. How would we write this equation? Okay, compared to how you would write just a regular inverse equation, but change the x to x squared. Say that one more time. If we were looking for k, that would be right. But switch it so that it's y equals. We're doing the actual inverse variation equation. Right? K over x squared? Yeah. Y equals k over x squared. Then there are ones like this third one that change the wording and say something like jointly. When you hear the word jointly, you should be thinking the same thing as if it said varies directly. In the case where it varies directly, you're usually multiplying. So you're going to do the same thing with varies jointly. Usually with jointly, though, you have more than just one variable. It'll say jointly with this and this. So I'm going to put this here so we remember that. Directly, jointly, directly, kind of interchangeable, but jointly has more variables. The k is still going to be here, even though it doesn't say that. So this is going to be z equals k times x times y. You're just adding on more variables. This next one now has varies jointly and inversely. Well, we know this part, because that's the same thing. So we can write that part. Z equals kxy. How would we write and inversely with w? Willow? Divide this entire side, the right side, by w. So when you see inversely, you should be thinking, I'm going to divide this variable. Directly or jointly, I should be multiplying these variables. So I want you to take a second and try this last one. And then we'll come back and I'll see what you guys made. We're good.
You can't even afford jeans, bro. Why are you talking?
What do we think this one is? Any guesses? I'm going to write this part. Z varies directly with x. Not minus. I'm sorry, did you say times? Sorry. K times x. Okay, so we have that part. And inversely with the product of w and y. How would we write that part? Yeah. So we're now dividing, but these two things need to be multiplied. It looks more complex than it really is. We just have to remember what's what. Directly, jointly, we're multiplying. Inversely, we're dividing. Now, it did say with the product of, so we had to multiply in there too, but we were dividing that entire thing.
Some guy gave me food and a drink.
Some guy you didn't know?
No, just some random guy just came up to me, gave me 3 talkie bags and a drink.
I find that hard to believe, but okay.
I knew about it.
Yeah.
What I mean, so
Notes.
everything?
Notes, yep.
Also,
Alright, now let's go through some examples. So remember, like I said before, some of these are just going to be direct, some of these are just going to be inverse. So that part's not going to be new, it's just going back and forth. So we have to remember the methods and how to set them up and things like that. There will be some that has both, and then we need to set it up and do things like that. So for all of these problems, I'm going to solve them all exactly the same, because it'll help you when we get to the ones that have both in them. So first thing you should do with these is set up the equation. So for number 1, variable m varies directly with p. How would I set that up? Look back at the examples we just did. Maddie. M equals k times p. These aren't the y and x that we were using before, but that's okay. As long as you know what goes with what, you're good. So now that we know that, we are given m is 75 and p is 10. So I'm going to put those two in. and we're going to solve for k. So this is like solve. Usually we find k and then put it in the equation, that method. This is basically what we're doing, or going to do for all of these. Divide both sides by 10. I get 7.5 equals k. So with my k value, I can say my equation is m equals 7.5 p. And then we are given, the last part says we need to find m, and they tell us p is 16. So now that we know k, we can put 16 in for p and figure out what that is. Someone multiply that and tell me what that is. 120. Now, in this case, would the method of setting it up like a proportion still have worked? Yes. What was the thing? Proportion. You could have done this as the proportion, but what I don't want you to do is start to get confused as to how would I do the proportion or the equation method when we get to the combined examples, because that could get messy really fast. Questions on number 1 before we move on to number 2? For 2, we're doing the same thing. But now R varies inversely with the variable t. Varies inversely. How would I set up this equation? R equals k over t. Doesn't matter that they're not y and x. You just have to know how to set up the equation. Inversely, we're dividing by the variable. Okay. Then they tell us that R is 168 and T is 24. How would we solve this for K? Multiply 24 on both sides. Someone do that and tell me what that is. $4,032. I think that's right. Yeah. Right, so now we have our K value, so we can put that back into our equation. R equals 4,032. Here's 3. And then put in the values they gave us. We need to find R when T is 30. Divide that, tell me what R equals. Yeah. So if it's just one or the other, solve it just like normal. Questions on number 2? someone just asked me, so let me let her go, and then when she gets back. We're going to do 3 and then skip to 5. This 4 is just another varies inversely, but it's an application problem. So for 3, we now have variable y varies jointly with p and q. How would I set that up? Y equals k times p times q. Jointly, we're multiplying the variables. Then we can put all of our numbers in. So in this case, they're usually going to give me 3 numbers instead of just 2. So 144 equals whatever k is times 12 times 8. So with this, you can do one of 2 things. You could multiply and then divide. You could set it up like you're dividing first. So get rid of 12 and 8 at the same time, and then multiply that and figure out what it is. Put it all in at the same time. There's a couple different ways to do that. Let's say we multiply this first. What is that? 92? Yeah. Yes. Switch the order of these 2. And then divide both sides by 96. What would that give us? That is correct. So then when we go to put 1.5 back in, again, we're going to be given, in this case, we're only going to be given 2 of the numbers now because we need to find one of the variables. In this case, it's y. So we need to find whatever y is. K is going to stay the same. Our p is 15 and our q is 25. Multiply those and tell me what you get. Yes. So are these more difficult? Not really, because you're doing the same thing. They're just set up differently, so you have to solve them a little differently. Do we have any questions on number 3? We're going to skip 4 and jump to 5, and then we're going to do a couple of the applications, and then I'm going to let you practice. Number 5, variable t varies directly with the square of m. How would we write that or set that up? T equals K M, but it's the square, so it'd be M squared. So then when we put everything in, we have to remember that M is squared. Don't lose that. Put your number in parentheses when you put it in. So we have 8 equals whatever K is times 2 squared. Or you can change that to a 4 immediately, either way. And then you could solve for K. So square your 2, divide both sides, we get 2 equals K. And then we can put that back in and start solving for whatever else is missing. So now we have to find T when M is 4. Again, don't lose your square. Put your number in parentheses. And here we have 2 times 16, or T equals 32. Questions on number 5? On the next page, we're going to skip to number 3. Because that is the first one that has both. These don't give you variables, so you're going to need to make up your own. Whatever variables you call those, as long as you're consistent, that's fine. So let's read this first. A video store runs DVDs, and the weekly total number varies directly with the total inventory and varies inversely with the cost of the rental fee. Varies directly, varies inversely. Before we get into the rest of that, let's put variables to everything else. Weekly total, you can call it W, call it T, call it M, doesn't matter. Total inventory, call it T, call it I, doesn't matter. And then with the cost of the rental fee, call that C, R, not T unless you put it lowercase. If your variables are different than mine, that's fine. So before we put all the numbers to it, let's just think about how to set this up. The weekly total varies directly with the total inventory. Let's take it step by step. How would we set up that part? W equals KT, and I'm going to try and keep this color coded. We'll see how well it works. And varies inversely with the cost of C. How would we write that part? Divide everything by C. So we have our equation. After that, everything else is going to be the same. We're going to put in the numbers, we're going to find K, then we're going to use that K to find the missing value. So the store half meeting in New York last week rented a total of 3,000 DVDs. Number of DVDs, weekly total, that's going to be your W. We don't know what K is. Its inventory was 9,600. And the cost per rental was $2.40. So I said before we keep reading the rest of that, we can solve this part for k because we know we're going to need it. So you can do one of two things. Divide this first and then divide it again, or multiply and then divide. Either or, you're going to get the same answer. Let's say we multiply this first. If you divide it first, that's fine. This just won't be that method. I don't know what that is. It probably would have been easier to just simplify it, but it doesn't matter. From there, I can divide both sides. To get 0.75. I'm going to leave it as a decimal instead of making it a fraction, just because it's already in a fraction, the entire equation, and I don't want a fraction within a fraction. So now we have our equation is W equals 0.75 T all over C. And then our last thing we need to do is the last part of this. So if inventory does not change, that means that's not what I called it, T stays 9,600. And we need to know the effect on the weekly total, so we're looking for W, and C is now 3. So we're looking for W, our K stays the same, our T stays the same, and our C changed to 3. You can put 0.00, but it's not necessary. You could really put this all in your calculator all at the same time. If you do your alpha y equals and put this in as a fraction. But what would W equal? What did we get for that answer? 2,400. Remember that your applications need units. W was weekly total number, so total number, weekly total number, how do you remember that? And the process is really the same, there's just more variables now. Do you have any questions on 3? I'm going to do one more and then I'm going to let you guys practice on your own. Let's do number 5. Sure. Okay, for 5, a ball is dropped from a window of a building. The distance it falls varies directly with the square of the timer clock. So in this case, we only have 2 variables, not 3. Again, we don't know variables, so call it what you want. Let's say this is D, for distance, and the square of the time t it falls. To set up that equation, because it varies directly, that would be d equals tk, I'm sorry, k, t. But t would be squared, because it says the square of. Then for our information, we know the ball can fall 8 feet, that's our distance. We don't know our k, but we know our t is 0.5. So we can solve for k. For this first, we get 8 equals k times 0.25. And then divide both sides by 0.25. So that k equals 32. Yes, we got a bigger number because we multiplied by a fraction, or divided by a fraction. So we really multiplied by 4 instead of 1/4. So our equation would then be d equals 32 times t squared. And we need to find d when t equals 2.5. Figure out what that is. What was that distance? 200. And then our units here would be feet. I realize that this wasn't the one I wanted to do, but that's okay. Okay. For the remainder of class, there are many practice problems in this. So the application problems, 1, 2, 4, and 6. The ones from the previous page, just number 4. And then the ones that we didn't do from this front and back page. Go through as many of those as you can. Let us know if you have any questions, but you have this time to work. Yes. Yes, I feel like someone else also just asked me, but I don't remember. Yes. Starting with this page, the back of this page. The answer to number 4 was 114.3. I don't know what to do.
Let's talk more. What's good?
Okay.
Okay. I just want to show you that it's good.
So this one was just various inversely. To set it up like the normal equation, find your k, and then for everything else to find d. As I mentioned before, these are on Canvas. So you can find those there as well. So don't feel like you have to write all of these down right now. Okay, so for number 1, this one just varies inversely. So you have to divide, find K, then find your life expectancy. So here it was a 2-part because the life expectancy was 17.5 years. Then it asked, does this appear accurate for humans? No. Otherwise, many of you wouldn't be in this room. And then number 2 was a varies directly and varies inversely. So it was a combined. So whatever you labeled your variables as, just make sure you're multiplying and dividing. Find K, find your time. The 40.5 hours would be your time. And then on that, 4 is actually the one I wanted to do, but that's alright. So this one is a varies directly and inversely. So make sure you're multiplying and dividing. The distance you're looking for should be 225, and then make sure you have your unit of feet. The last one that I'm going to go over really quickly, this answer is wrong on Canvas. I did just fix it, but if you were writing this down, make sure you have this as well. The answer should have been 51,250, but the answer on Canvas is not that. It's like something way bigger. So ignore that answer on Canvas. This is the current one. If nothing changes with school, be prepared, those of you taking your benchmark on Friday, to take that or finish your work so you can take that. If you're missing tests, you'll also be taking it that day. And then next week will be our quiz and tests. So start practicing for that. You guys don't have any new Khan Academies or Delta Math, just the same 2 that were already.